Hello, everyone. Warm welcome to this panel discussion. Space is closer than you think. Tech that change Earth today. That's the topic of our discussion. Many people think about space, they think about rockets, astronauts, Mars, moon, all those things. At least that's what my kids at home think that I am doing and I am working with. But today we are here to explore another side of the space business. We will discuss space technology and how space technology can help us to understand what's going on Earth. My name is Magnus Andersson. I'm an academic. I work at Malmö University. I'm a social scientist. So I'm a bit of an odd bird, at least in this conference. But what I've been doing for the last 20 years is using space technology to look at human activities on Earth. And with me today, I have an amazing panel. I have two persons who have been doing work using space technology for some time. With me today, Chan-Kun Chen.
Good afternoon, ladies and gentlemen. Welcome.
You are the co-founder of a business called Kravi Analytics.
Yes, that's correct.
And you are using space technology to provide an holistic maritime monitoring tool.
Yes, that's correct.
But besides being a person working with space technology, you're also a doctoral candidate in traffic safety at Lund University.
That is also correct.
Very busy.
Yeah.
So we have also Olof Bengtsson. Olof Bengtsson, you are a software developer specialized in AI and machine learning, with a background in engineering physics at Lund University, and you are working at a company called Green Urbansights.
That is correct, yes.
That is a startup working using satellite data to get better insight on urban tree management.
Exactly. So we gather data to get a point cloud, and from that point cloud, we detect where all trees are in an urban area, so that we can map them out. And by knowing where they are, we can also monitor them over time. So we gather some other satellite data to get an indication of their vitality, so that we can monitor them over time and give alerts if they fall under a threshold or if they appear to be not feeling very well. So giving regions, municipalities and cities better understanding of their urban tree management, you could say.
And this is one of the good examples on how we can use space technology today. And space technology and space business has shifted quite a lot during the last 5-10 years, from being very focused on government led missions, exploring space, to an industry that allows smaller firms, startups to get engaged in the ecosystem of space business. And you are just very good examples on how we can, what opportunities there are, and so on. So, Chen, could you? I know you have some really amazing work on your desk. Would you mind to tell us a little bit more about what you are doing in your business?
Definitely. So thank you very much, Magnus, for the introduction. So in our business, what we are focusing on is to use the space technology to detect the illegal, unregulated, and unreported fishing. The idea is that when we are going on the ocean, right, every boat, as long as they are big enough, they are equipped with an AIS transponder. But if you want to commit suspicious activities, then you don't want people to know you are there. So what people do, they switch them off, and then they become what commonly known as the dark vessel. But hey, what we are here is to identify and track those dark vessels. And we want to provide these informations to the government authorities in the territorial water so they can send out legal reinforcements in order to stop those illegal, unreported, and unregulated fishing. That's a really long name. But I consider our vision, the company's vision, being to promote the biodiversity in the marine and also help to improve the economical equity in the countries where fishers are suffering a lot from those kind of exploitation. Yeah.
Good.
Thank you.
Thank you. Thank you. It gave us a better understanding of what you're doing, and I can see a few things that is coming in between of you. We're talking about biodiversity. Both of you are doing that. But when we talk about satellites and images, what type of images, what type of information do you have in the images that you study, Olof?
Well, I can imagine that it's quite different between you and me. But for us, as I said before, the first part for us is to get LiDAR data, which is point clouds, where each I don't know how if that's common knowledge what that is, but basically it's you get a 3D scan, you could say, with points in a 3D space, where each point is mapped to a class, where a class could be that it's part of some kind of vegetation, or it could be a building, for example. It could be the road. But for us, of course, the interesting part of this data is the vegetation, to understand where all the trees are. So that's the first kind of data that we're working with. And then we combined our findings from our processing on that data and use them with vitality data that we can also get from satellite sources to get the idea of how of the vitality of the trees, if they're feeling good, if maybe they're sick, maybe they need to be cut down before they can collapse over. It could be a bike track, for example, which could hurt someone. But so combining data sources is extremely powerful, and the data sources are very accessible as well. I think that maybe you've seen that as well.
Yeah, exactly. So even though we are saying that we are trying to detect dark vessels, but of course we also want our system to track normal vessels. So it's not enough to only using satellite data, but also to fuse the data with other sources. Like in our case, we are using the AIS, which stands for, or VNS, vessel something number. So it's basically the number that tracks the vessels. So we are combining the satellite images with the time in different time frame, and also with the AIS data in the certain time frame. And of course, there are more sources of the data, but I cannot tell too much. So it's business secret. Yeah.
So there's another thing that comes up here is running a business. And for me, doing research, we need to be cost effective. And I think a common thing among all three of us is that we can access data that is available.
Oh, true, yes.
And most of the data is freely available, right?
Yes.
So that's one strength that we carry with us when we run our businesses or when we conduct research. But let's talk. May I ask you, what's the main challenge when you work with the topics that you deal with? Is it getting the data, processing it, or is it interpreting the data? How do you feel about that?
Okay, I can start. Okay, so, well, I mean, I can talk about the challenges for days, but let's be short. So first of all, satellite data are big, and the area we are focusing on is very small. So I was playing the puzzle at the beginning of the conference today. So it's basically the same idea. So consider you are in the ocean, and the ocean looks blue, nothing else. And you want to find a specific anomaly in the ocean. So how do you make sure that you are looking at the right area? Also, that's our major technical challenges. Because first of all, each satellite data, they have very huge size. It takes time to download them, and it takes time to process the images, and it takes time to identify the images. And in order to identify those in a real time, it takes massive data infrastructures. So that's what I would describe as one of the major challenges today. What do you think, Olof? Do you agree with me?
For sure, I agree with you. When working with larger areas, it's very difficult to actually get the full data to run on normal hardware.
Yeah.
The amount of data that you actually need to do something can be mind-blowing sometimes. But I also see another kind of problem, which is the data resolution.
Yeah.
Because when we're looking at smaller areas, for example, a tree, and we want to monitor a tree, it's important that we don't include data from 20 different trees that are nearby, because we're only actually interested in looking at one specific tree. So the data resolution is a very big part, which I can only imagine is the same for you.
Yeah, that's true. Because for us, let me get back to the dark vessels. I'm really into that. Sorry, guys. So identifying the vessel itself is not enough. So we also want to know, okay, where this vessel is coming from and where this vessel is going to, right? But if the vessel is dark, which means they don't have identification numbers, then how do we know this vessel in the next hour is the same vessel as the vessel we detect an hour ago? So from a research perspective, this is called a re-identification problem. So, and the resolution of the data matters, as the machine learning models requires those features in order to draw conclusion on the classification, whether they are the same vessels or not. So I consider that as a very valid point. It is indeed a difficulty in processing the satellite images and use it for analytic purposes.
And when I listen to you, I'm thinking about problems that occur at my university. We are focusing on social science. We use heavy technical intensity methods, and the people I need in my research teams, they're developers. They're here. So one thing that is in big need for us is developers that can help us to process, but also to think new, to provide us with that knowledge that I am trying to find in my dreams, because I dream a lot about the opportunities we have using satellite images. How about you? Are you looking for specific competences?
Yes, of course.
Yeah.
Of course. Yeah. Where I can only think that we have the room full of people with the correct kind of knowledge. But yeah, of course, we need more people working with this. It's very important. It's a very exciting field, but just working with large amounts of data, maybe for us, I think it's geospatial data in general is a very big plus. But if you don't have explicit knowledge, I wouldn't discourage you from trying still, because it's very interesting, and you will learn.
Yeah, I have a comment to add to Olof's just said, is that because when we are looking at a traditional remote sensing setting, is people either doing a geophysical major or doing a humanity major, or so none of them are very into the software development ecosystem. So they may be able to program algorithms that is specifically target for certain type of mission, but they don't know how to integrate this in a software as a service. So what are the data infrastructure is required for those purposes? So people usually lack the knowledge. And then I think it's important to have an interdisciplinary perspective between software developers or software engineers and also researchers in the field, like you, Olof.
Yeah, exactly.
I think it takes us actually to conclude our panel, to our stimulating discussion, because I think people are starting to enter the other sessions. But before we do that, I want to highlight a few takeaways. So, first of all, remote sensing satellite images, they're accessible.
Yes.
We can start to use them.
And they are free as well.
And they are free.
Yeah.
Exactly. That's very important. Another thing is that software and software development is one of the main bottlenecks. However, we want to highlight the ecosystem of space technology. Space is accessible. Space is there. There are business opportunities. And allow me to say just a few words about what opportunities we have. And in Lund, at Ideon, there is a European Space Agency Business Incubation Center called ESA-BIC. Check it up online. They are helping out to make startups grow, both through competence, but also through funding. So there are opportunities for those of you who start to think about space. Those of you who want to speak with us after this panel, we will be in the speakers' corner after this discussion. And we would very much like to hear if you have ideas to get engaged in the space technology and the space ecosystem. So with that words, I would say
thank you
to the audience.
Thank you, audience.
Thank you to Olof. Thank you to Good.
Thank you very much.
Thank you very much.
Have a nice evening. Yeah.
Have a nice evening. Thank you.
Yeah.